Reading: How are tsunamis detected and warning signals sent? Why did a tsunami reach Japan in 2011? Earlier we read that a magnitude 9.0 earthquake happened underwater off the eastern coast of Japan on March 11, 2011. We figured out that earthquakes like this one are strong enough to cause large parts of the ocean floor to crack, tear, and move. These movements of the ocean floor push water away from the location of the earthquake epicenter in all directions. Very large waves form and can travel at speeds of 500 miles per hour. They can reach coastlines around the world in less than a day. In 2011, the first waves reached parts of Japan in only 8 minutes. With so little time to respond, detecting tsunamis quickly and accurately is essential. How do we detect a tsunami? As we read above, an underwater earthquake started a chain of events leading to the 2011 tsunami. So, this means that we must first detect the earthquake that causes a tsunami. Scientists on land have special instruments called seismometers that detect and record earthquake activity. By using seismometers in different locations around the world, we can figure out an earthquake's location, magnitude, and depth. This information is important to scientists. Remember, we have learned that not every earthquake causes a tsunami. In fact, earthquakes must meet 3 criteria in order for a tsunami warning to be sent. Think back to what we learned in previous lessons. What types of earthquakes cause tsunamis? In order to cause a tsunami, an earthquake must meet 3 criteria. First, it must occur underwater. Most earthquakes that occur on land do not cause large movements in the ocean floor. That means they do not lead to water movement and waves. Second, an earthquake must release a lot of energy to cause large parts of the ocean floor to move suddenly. The amount of energy released by an earthquake is measured as its magnitude. Magnitude is sometimes referred to as the strength of an earthquake. Weaker earthquakes may not move the ocean floor enough to cause a large wave to form in the ocean. Lastly, an earthquake must be shallow and not deep inside Earth's crust. Shallow earthquakes tend to occur just below the ocean floor. This can cause the ocean floor to move more. How do we locate a tsunami? The second step of the tsunami warning system begins when seismometers detect an earthquake that might cause a tsunami. This step uses a system of special instruments. The instruments are located on the surface of the ocean, on the ocean floor, and even up in space. This system of instruments is called DART-II, or Deep Ocean Assessment and Reporting of Tsunamis. When the seismometers on land detect an earthquake that might cause a tsunami, they send a signal to a satellite that is orbiting Earth. The satellite then sends signals to several floating buoys on the surface of the ocean near the earthquake's epicenter. Next, each surface buoy sends a signal to wake up an instrument down on the ocean floor, called a tsunameter. You might be wondering why we don't send a signal from the satellite directly to the tsunameter. It turns out that satellite signals do not travel well through water. Fortunately, sound travels very quickly through water. So, sound waves, or sonar, are used to send and receive signals from the tsunameter. How does a tsunameter work? A tsunameter is anchored to the ocean floor. It has several devices attached to it that float upward. As a wave moves across the ocean's surface, the water underneath the wave gets pushed down deeper into the ocean. If a large wave occurs, more water is pushed down, which also pushes down on the floating devices attached to the tsunameter. The tsunameter records the height and movement of these floating devices every 15 minutes when it is in sleep mode. When an earthquake occurs nearby and the tsunameter is switched to active mode, it takes measurements every minute. Stop to wonder, why do you think the tsunameter is sometimes in sleep mode and not always in active mode? When a tsunami occurs, a huge wave moves across the ocean's surface, pushing large amounts of water down on the devices attached to the tsunameter. Once the devices sink to a certain depth, the tsunameter sends a signal back up to the surface buoy, telling it that a tsunami was just detected on the ocean surface. When is a tsunami warning sent? On the ocean surface, The surface buoy sends a signal to the satellite. The satellite then sends a final message back to the scientists on land. The scientists use computers to predict whether the tsunami will reach the shore. If they think the tsunami will reach shore, then they work to figure out the answers to these questions. 1. How long will it be until the tsunami hits? And 2. How tall will the wave be when it hits? The answers to these questions can be used to help save lives.